Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, and thank you for joining our OAB Online Learning Hub. We're delighted to be hosting today Mahmoud Abu Zamel from ProgressSoft, who will talk to us about blockchain. And I think blockchain is probably one of the most heavily debated technologies and also the least understood. If you have any questions during the presentation, please ask your questions in the chat window, and they'll be addressed by our speaker at the end of the presentation. Mahmoud, thank you so much for joining our learning series. Many organizations globally are developing some interesting use cases using blockchain to solve either current business challenges or future ones and to gain competitive edge. What makes this technology relevant in today's world? Over to you, Mahmoud.
Okay. Good afternoon, everybody. I'm delighted to join you in this session. I'll try to simplify the concepts and principles behind the blockchain, distributed ledger technology, and a new thing that's arising on the atmosphere called IOTA. You might not have been heard about it before, but we will talk about it. So to start with, let's take a look at our agenda. I'll be talking about what are mutable databases, what is blockchain, what is distributed ledger technology, and I'll be talking a bit about the permissioned concept. Of course, when we say permissioned concept, we will be also talking about the non-permissioned concept. We will be talking about the consensus protocols used in blockchain networks, and we will be introducing a bit about the IOTA approach. Then we will be talking about the development and operational platforms available in the markets and the potential use cases and the tools that you may need to care about when you approach development of a blockchain or distributed ledger technology solution. So first is first is talking about what's so-called immutable databases. Maybe most of us know about the traditional relational databases. They are mutable and they follow a design approach that's called CRUD. This means that you can create, you can retrieve, you can update, and you can delete from a traditional relational database management system. On the other hand, an immutable database, which is called WORM, stands for write once, read many. It allows you to create and to retrieve, but it does not allow any updates or deletes. And that's actually the type of database being used by a blockchain solution, whether it being applying the solution for a distributed ledger or for some other sorts of solutions. So in its simplest case, what is a blockchain? I'm not going here to talk about the historical issues about the Satoshi Nakamoto who wrote that white paper that led to cryptocurrencies like Bitcoin and Ethereum and others. What I'm going to talk about is the actual meaning of a blockchain and its structure. In its simplest definition, a blockchain is nothing but a series of blocks chained into a sort of a linked list where each block points to the previous block. And these blocks contains nothing but transactions. So the transactions that are taking place in the network, whether it being financial transactions or non-financial transactions, they are grouped into blocks in some algorithm or mechanism. And then these blocks are pointing to the previous blocks in a chain. That's why it's called a blockchain. And these blocks of transactions are stored in an immutable database. So that means when a block is created, it can be retrieved infinitely, but it cannot be updated and it cannot be modified in any means. And next comes the distributed ledger technology. Actually, the distributed ledger technology has been always talked about side by side when we talk about blockchain. The first blockchain by itself is actually a distributed ledger. The distributed ledger technology has evolved from the cryptocurrencies and blockchains. But actually, if you look at it, you can distribute a traditional ledger among a series or a set of network nodes without using blockchain. So when we talk about distributed ledger technology, we say it might be or may be implemented using blockchain networks, but that's not a necessity. So if you think about it, you can use traditional RDBMS engines. You can form a traditional network of nodes and distribute a ledger among those nodes using certain technologies like database sharding, for example. Usually, a blockchain network requires a network of nodes or a digital ledger technology network as well requires a network of nodes that are synchronized with each other in terms of data replication. So the transaction that takes place in one node of the network getting propagated to all nodes within the network in order to be shared. So in that case, although we say it's a distributed ledger, but actually the more precise meaning of it is a replicated ledger. The permission concept. When the first blockchain networks and distributed ledger networks for cryptocurrencies been introduced earlier in 2008 and next in the coming few years until 2012, these networks used to be non-permissioned. What does that mean? Non-permissioned means that anybody anonymously can just download a copy of the ledger and contribute as a node within the ledger network or blockchain network. But when we discussed that at the level of authorization and the levels of legislative concerns of countries concerning central banks, governments, e-governments, and so on, we figured out that the contribution as a node within a blockchain or a distributed ledger technology network should be permissioned and authorized by a single authoritative authority. It depends on the type of distributed ledger technology or blockchain network being implemented, whether it being at a national level or at a constitutional single financial or non-financial institution level. In all means, there should be one single authority that's allowed to give permissions to other parties to contribute as nodes in that network. In this case, we call this type of network permissioned network. That necessity introduced a new role within the network that's called the identity management role. That sole authority that gives permissions should operate at least a certification authority and, if possible, an identity management solution as well. Every distributed ledger technology or blockchain technology network requires consensus protocols. You can imagine consensus protocols like the juries in the court. We acquire these juries' consent and agreement on something that's being happening. In our case, that is the transaction taking place within the network. So a set of juries that are represented by by the nodes forming the network need to agree on the validity of a transaction before that transactions get included within a block that will be included within the chain, or before that transaction is being really committed to the ledger. Some of these protocols, I arranged them historically here. The proof of work protocol that had been introduced in early 2008 by the Bitcoin cryptography blockchain network. And that protocol proved to be energy and power consuming, which means it's highly costing the network. It's really consuming CPU power, and even the miners have moved from CPUs to GPUs in order to be able to mine and do real work that proves their contribution in the consensus protocol. That protocol is not only consuming energy, but it's also slow because it requires highly cryptographic computations to be done until randomly figuring out certain values that contribute in what's so-called mining. So we started looking for a better set of protocols. One of these protocols is the proof of stake, where the nodes contributing within the network provide their approval on transactions based on the impact of these transactions being fraudulent on their stake. So because they have a stake within the network and they are concerned of not approving but a non-fraudulent legitimate transaction, their opinion is taken into consideration as part of the consensus, and that's called proof of stake. A third protocol is based on a historical story about the Byzantine leaders surrounding a castle, and they needed to make a decision to either retreat or attack. And that protocol is based on spreading a sort of a gossip message where everyone receives that message and they are supposed to reply on that message by their approval on the attack or approval of the retreat. And that's called the Practical Byzantine Fault Tolerance, PBFT. Another protocol is the proof of elapsed time, where it's based on timers, and every node will provide its consensus or approval on the transaction after an elapsed period of time that it changes along the lifetime of the network, so that the time might be increased or decreased in a random fashion, where the algorithm makes sense in that all nodes in the network will reply on their consensus and approval of a transaction within the accurate time being practiced within that moment. There is another protocol, but it's not meant really for consensus at the transaction level. It's called the Paxos protocol. It's meant for the replication of transactions among the nodes of the single network. That Paxos protocol, it's an older protocol, although it's efficient, but it was meant to be sophisticated and complicated to both understand and implement. That's why lately we came up with a newer protocol that's called the Raft protocol, and it's meant to replace the Paxos protocol by providing a simpler way of doing replication between nodes like the Paxos, but in a simpler way that can be understood. The last protocol that I'm talking about here is what's so-called any x of n, and that's actually an interpretation of the voting protocol, where the authoritative single node that gives permissions to nodes can set a rule saying that 5 of 20 is required to vote on the approval of a transaction in order for a transaction to be really approved within the network. The traditional thinking of distributed ledgers has been always talking about blockchain and blocks of transactions. But lately, some party came out with a new concept that reduces the chain from a block-based chain into a transaction-based chain. And they called it IOTA. Actually, the name IOTA is not related to any abbreviation. It's related to a word that has a meaning, and it really means a very tiny, small amount of a thing. And that actually related to the actual purpose of this network, because it's considering the Internet of Things that we all know it's coming in the coming few years, alongside with the 5th generation communication networks, where we are expecting things to be communicating with each other, making transactions without any human intervention. For example, cars on the streets talking to each other and seeing the potential of the car in front of you to decelerate or accelerate according to certain rules. Or even a refrigerator at your house talking to the store to ask for grocery and other stuff based on the lack of certain items within the refrigerator itself, for example. Now let's talk a little bit about the available platforms to implement a distributed ledger or a blockchain solution. So talking about the blockchain, let's focus that our distributed ledger as well is being implemented using blockchain technology. One of the most famous platforms these days is the Hyperledger Platform. Actually, the Hyperledger Platform started by IBM. There has been registered about 150 financial technology leaders and other associations and enterprises around the world, including banks, large banks in the world, including Cisco, IBM, and others. Later on, the project has been adopted as an incubator under the Linux Foundation, and it's actually gaining a very huge society and contribution from developers all around the world. Each of the platforms that we are going to talk about here did introduce new languages to use, and they are supporting some languages as API development or contract development. I'll talk about it a little bit. For the Hyperledger, it supports Golang, and actually it is implemented using Golang. It also supports Java, Node.js, and they are saying that Python is coming on the way in the coming few months. These languages are mainly used by the implementers of the DLT network using the blockchain based on Hyperledger platforms to implement what's so-called the smart contract. Every use case that we implement on a distributed ledger technology or blockchain technology should be based on a smart contract. And we will talk about smart contract later today when we talk about the use case characteristics. Another platform that you can select or adopt or choose is the Ethereum platform. The Ethereum platform is one of the most earliest platforms in blockchain and DLT technologies. What recognizes the Ethereum platform is its adaptation to a special language. They call it Solidity. And it's a bit similar to C++ and Golang. So if you are going to use Ethereum or adopt Ethereum, you need to learn, or your programmers need to learn the new language that's called Solidity. It's used for both implementing the network and developing the smart contract. A third one is introduced by the R3 Enterprise Corporation, and it's called Corda. Corda currently supports Java and Kotlin for smart contracts. And it's actually adopted by other platforms like the Quorum platform. If you take a Google search on these platforms, you will be finding that there are over 200 platforms right today. Some of them like the IOTA, Algorand, BigchainDB, Credits, and many, many others. What I want really to say and recommend here is that regardless of the platform that you choose, you need to choose a platform. So do not think of building the blockchain and DLT from scratch. You need to adopt one of those platforms, learn that platform, and do your use case contracts and implement them, develop them using that platform. It doesn't matter what platform you choose. You need to do your research and see what suits you. Some people do feel that the Hyperledger is a good platform. Some other people do feel that the Ethereum is a good platform, and others feel that the Corda is a platform of their choice. So that's why we mentioned these three platforms at first. Other platforms are there. You can investigate them and see about them. For us at ProgressSoft, we have chosen the Hyperledger platform. The Hyperledger platform is not a single approach towards DLT and blockchain. They actually have multiple implementations, as you can see. They have the Pisto, they have the Borrow, they have the Fabric, the Inde, the Iroha, the Sawtooth, and other tools that assist these platforms and distributed ledgers. And they have also some libraries that you can use, and they have certain domain-specific platforms. They do not only support the Hyperledger approaches of a blockchain, they also have some of these implementations like the peso that supports Ethereum as well. So you can go around them, you can see them. You can select one of these to implement depending on the use case that you see fit. For us, we found that the Hyperledger Fabric is one of the best of these platforms to implement a financial solution. And as well, it's good to implement a general purpose solution that might not be financial as well. So what forms a use case that's good to be implemented as a DLT or distributed ledger technology use case or solution or a blockchain solution? These are the main characteristics. If you have an asset that's owned by some party and that party have the choice to transfer ownership to the others or grant access to another party on its own owned asset, and that grant of access or transfer of ownership is based on a contract between those two parties, then this is a potential use case for a DLT. That's very simple. You can imagine how wide the range is applying these concepts and principles. An asset, two parties, transfer of ownership, grant of access, using a contract. That's it. You have a potential use case. So let's take some examples on the potential use cases for the DLT. The first use case that we might talk about is the central bank digital currency. And in this slide, I'm listing almost most of these use cases are financial sector based, while some others are not. In the next slide, we'll be talking about other use cases that might not even be in the financial sector, neither be in the traditional normal operational business sectors that we know. But let's talk about the central bank digital currency. As we all know, since that Bitcoin has been introduced in the 2008, about 40 to 45 other cryptocurrencies has been introduced as well, and they are now there. What's the problem with those cryptocurrencies? First, the network is not permissioned. What does that mean? It means that anybody can be part of the network. Anybody can mine the currencies. The currencies can be created and generated out of nowhere. And that leads to another pitfall of these currencies, that they are highly volatile. What does that mean? It means that if you buy a Bitcoin today for 12K USD, for example, it might get to be 28K USD tomorrow, or it might get to be just a few tens or hundreds of USD dollars in a few days. That's volatility. You might lose too much stake within a short period of time. That's why if we wanted to convert the money that we are dealing with today into another type of a non-volatile money, that money should be governed by the central bank of each country. That's why it's called the central bank digital currency. In this sense, the central bank will be the sole authority that will give permissions to other parties to contribute within the network as nodes. In that case, as you can see, we will be building a permissioned network. The sole authority is the central bank. Its main purpose is to provide a replacement of the what we call fiat money, which includes the banknotes and normal metallic coins that we are using day to day. Instead of those, we will be using a cryptocurrency that's controlled by the central bank. That's one of the use cases. Back to the concepts that make this a potential use case. The asset is the currency, being the banknote or the coin that's being used within a specific country. The owner is the one who holds that banknote in his or her pocket or wallet. So if I have a banknote of 10 Omani riyals, for example, then I am the owner of that 10 Omani riyals. And that 10 Omani riyals banknote is the asset. Being an owner, I can give ownership of this 10 Omani riyals banknote to another party, say the grocery, for example. So there is another party, and I can give ownership to that party in exchange of goods or services, and sometimes. So there is an asset, there are two parties, and there is ownership, and I give the ownership to another party. Well, what is the contract here? The contract is this: I give you the money in exchange of giving me the goods from the grocery. So there is a contract. In this sense, this is a potential use case to be developed as a distributed ledger or a blockchain distributed ledger technology use case. Another case is the e-mandate. I don't know if most of you know about the mandate concept. In the financial sector, we have something called direct credit and direct debit. In the case of direct credit, the owner of the account asks to credit another's account with a specific amount of money. But on the other hand, in the debit transaction, we give an authorization to another party. For example, I am as a user of a telecom service, I give an authorization to that telecom service provider to deduct the amount of bill, monthly bill on my phone from my account. So actually, the initiator of the transaction in this case is the telecom company that's been given an authorization called mandate to do a direct debit transaction from my account. So now that mandate can be managed using a blockchain network. The mandate is the asset. Me and the telecom are the two parties. And the grant of access or use of that mandate I give to the telecom based on a contract between me and the telecom company. So this is another use case for a DLT or a blockchain network. eKYC, a third potential use case. The KYC, or Know Your Customer, is a concept that's being widely used in the financial sector, telecom sector, and insurance sectors, that you need to know your customer in terms of identity, recognition. You need to know who they are, how do they look, are they males or females, where do they live, what are the services that are acquired by these customers. In the process of collecting know your customer information, we are required to collect certain attachments that become as assets. These attachments include national ID photocopies, passport photocopies, residency, address, proof of address, being an electricity bill or a utility bill or something like that, that proves where you live. All these assets are given voluntarily by the customer, who is the original owner of these documents, to the service provider, being a bank, financial institute, insurance or telecom, to contribute as part of their know your customer information. So we have an asset, we have two parties, and we have a contract to use. This is another potential use case of a blockchain or a DLT. EID as well. The government issues IDs, national IDs, passports, and those IDs are being used as an identification asset, where it can tell that the holder of this ID is who claims to be. So there is an asset. There are two parties. The two parties can be, at certain occasion, the government that issues the ID, and the citizen or resident who takes that ID. In another scenario, the holder of the ID, being a citizen or a resident, and the party that needs to verify that ID. So you grant access to the information in the ID for that party to verify your identity. So this is another use case for the blockchain or digital ledger technology. LCs and LGs, letters of credits and letters of grantees, that provides a sort of contract between a buyer and a seller cross-border, facilitated by two financial institutes. Each financial institute resides at one of the two parties' country, so that this can provide means for those two parties to do exports and imports of goods in exchange of promised money to be paid. Again, there are assets, parties, and contracts to be executed. Cross-border remittances, to transfer money between accounts. So one account is owned by a party in one country, another account is owned by another party in another country, where the first party grants permission of transfer of money from one account to another account using a special contract. Insurance contract. The insurance contracts between the insurance companies and the insured parties. It is an asset. It's a contract between two parties, and there are two parties, then it is another use case. Insurance claims, or what we call e-claims. Insurance claims are widely used in forms where each form consists of a few pages, carbon copies, maybe 6, where one copy goes from the doctor or clinic that receives the patient. Another copy goes to the laboratories that do the tests, blood tests, and other types of tests. A third goes to the pharmacy, and a fourth goes to the laboratory that does x-rays and so on. And all those are forms that represent assets. And finally, all those parties get paid by the insurance company based on receiving the contract terms. So we have multiple parties, we have an asset, and we have a contract among those parties. Each party fulfills its terms of the contract. Let's talk about another set of use case examples. File sharing. Today, there is a platform on the internet called IPFS. It stands for an IP, which is the IP address of the machine that you are using, file system. And it is a sort of an internet protocol file sharing solution. And it can be based actually on blockchain. Why? Blockchain is not only about having blocks of transactions that are in immutable database. Blockchain provides security of transactions being in the network. It provides integrity of data being stored within the network, and it provides immutability of this data. So if you wanted to share a file with some specific party, so the file is the asset, you are the owner of the file, you are the first party, and you want to deliver that file to one or more other parties to either own it or use it. Let's take an example of file sharing. It's general purpose media sharing. Netflix. So Netflix owns files that are media of series and movies, and they grant access to stream to certain subscribers based on the contract of the subscription being paid on monthly basis or annual basis or per selection or per movie, like on Amazon online. So file sharing is one of the potential use cases. You might be astonished about this next use case, which is the diamond certificate, and actually it's an existing use case. Certain assets like diamonds and horses require identification of the history backtrack, or what's so called the family tree. So they created a blockchain-based digital ledger that certifies diamonds and tracks their transfer of ownership from one party to another, from their initial mining in South Africa, for example, until the arrival to the store or custody of the final owner. So there is an asset, that's the diamond piece, and certificate of that diamond. There are two parties, the party who currently own the diamond and the party who will be owning the diamond later. And there are contracts between these two parties to transfer ownership from one party to another. Same said regarding the horse family tree. Healthcare historical records as well are a potential use case for blockchains, and a credit bureau where the credit score of citizens is given on a blockchain ledger, where the scoring is coming from the consensus of multiple bureaus. Like in the United States, for example, they have the triple A where three parties are scoring people for their credit. So if you have a AAA, then you are in the best form shape. If you have a DDD, then you are not credible that much, and so on. That credit bureau can be easily implemented on a blockchain as a use case, where the asset is the credit score, and the parties are the creditor who gives the score and the citizen who had or holds the credit score. What tools you might need in order to be able to implement a blockchain solution or a distributed ledger technology solution? First of all, as we mentioned earlier, you need to select a platform and deeply understand that selected platform. So if you select Corda, or you select Ethereum, or you select any of the Hyperledger platforms, you need to dig deeply into understanding that platform in terms of structure, architecture, network, deployment, development, and operation. Next, you need to know about the cloud. Why am I mentioning this type of knowledge or need about the cloud? Because most of these platforms are providing their services as software as a service over the cloud. So Hyperledger, you can find a Hyperledger on the IBM Bluemix. You can have Hyperledger implemented over Amazon Web Services. You can have it implemented over Microsoft Azure. Same said for Ethereum and other platforms like Corda and Oracle Blockchain. You will find that they are provided as cloud-based solutions. Does that mean you cannot adopt them as an on-premise solution? You can. Of course, you can deploy any of these as an on-premise solution, but it's much, much easier to spin them out in few minutes over the cloud and focus more and more on your smart contract instead. If you go the other way around and you try to implement them as an on-premise solution, you will be consuming much of your time and effort and cost on trying to understand how to deploy them and configure them and maintain them and operate them on your on-premise infrastructure. One third thing that you need to care about is the programming languages. As we mentioned, most of these are introducing new paradigm programming languages, either general purpose programming languages or specialized programming languages. So for example, if you go for Ethereum, you need to learn the Solidity programming language. On the other hand, if you go to the Hyperledger, you might need to understand Golang if you intend to write your smart contracts using this language. Otherwise, it's good if you already know Java or Node.js, you can implement your smart contracts using these languages. But if you go to develop an on-premise infrastructure, definitely you will be in need of understanding the secrets behind operating a Golang or a Solidity solution. The last two things are recommended from my side, that you need to build your CI/CD, which stands for Continuous Integration, Continuous Delivery platform when you develop your smart contracts. And you need to facilitate a DevOps platform, which stands for the development and operations put all into one team and one platform and one process instead of having development separate from operations. That's a wider topic that you need to care about and look at. And that's it. I will be leaving the last few minutes to answer your questions.
Thank you, Mahmoud. Thank you very much for this very insightful presentation. And thank you, ProgressSoft, once again for being part of these webinars. If you'd like to ask your questions, please raise your virtual hand or type them out in the chat window, and Mahmoud will respond to them. We've got a question from Ala Lawesi. Ala, I'm just enabling your mic. Please go ahead, Ala. Ala, sorry, you might need to be speaking to the mic. We can't hear you very clearly. Okay, I think that he has an issue with his mic. We'll take the next question. So Mahmoud, while we wait for the questions to come in, what advice would you give students who are currently on this webinar in terms of blockchain platforms that you would recommend if they're looking to develop a new solution? I know you've briefly covered some of the platforms and the pros and cons for each, but what would you think is the simplest way to get introduced to this technology?
Yeah, actually, in the past few years, we've been digging into the blockchain technology for about 5 years now. And we've been, let me say, jumping from one platform to another. We tried almost 10 to 12 platforms since that time, but we found that the Hyperledger, and specifically speaking about the Hyperledger fabric, is the most easiest one and straightforward one to adopt. First, we tried to go the hard way and tough way to implement it on premise, and it consumed most of our time until we figured out that we can spin a whole network on the cloud using the IBM Bluemix or Amazon even. That saves you time to have your network up and running so fast, and you focus just on developing the smart contract. What I also recommend if you are adopting the Hyperledger is to use the new tool introduced by the Hyperledger that's called Hyperledger Compose. That tool allows us to build the network so fast. It's called the Hyperledger Compose. And there is another tool that is used by Hyperledger. It's called the Hyperledger Explorer that allows us to visualize the transactions being taking place on the Hyperledger network while it is on the cloud.
Great, thank you. We've got a number of questions coming in. So we've got a question from Emmanuel. His question is, in today's world where enterprises need to integrate with each other, how do we manage if each enterprise has their own blockchain platform?
So you are talking about interoperability among different blockchain platforms, and that's actually being a topic tackled by almost all network platforms. Lately, we figured out that need, and yes, now most of the platforms that are named, including Hyperledger, all platforms, Ethereum, and Corda, are interoperable with each other. They allow interoperability through bridging that provides some sort of adapters from one platform to another. So what you need to do is to understand what are the bridging tools that are provided by your platform and to what other platforms they can connect. In some cases, they are calling them connectors. So you can have a connector from Quorum to Hyperledger, for example, and there is a a connector from Hyperledger Fabric to Ethereum. So you can do that sort of connectivity.
Thank you, Mahmoud. There's another question from Fatma. What are the biggest benefits of using a blockchain platform for international remittances vis-a-vis the traditional way of doing transfers?
Okay. That's an interesting question, actually. For those who know about the way that international remittances are being carried out today, and you might be at a question of why am I paying that much to do an international transfer from one country to another? For example, in some countries that might go from $15 to $45 per transfer, depending on the amount of that transfer. Those international remittance transfers are being carried out using a SWIFT network, where SWIFT network has some cost imposed on the financial institutions, both the receiver and the sender. By using a direct peer-to-peer transfer between correspondents, you might be implementing something like Ripple X Current, for example. Ripple, I did not mention the Ripple network in my presentation, but they are one of the cryptocurrencies that are there. And lately, they have introduced a special peer-to-peer mechanism of transferring money using a blockchain distributed ledger technology between the two peers as directly connected to nodes. And in this case, almost the whole cost of the remittance between the two countries is being truncated, giving the luxury for those who adopt this mechanism to offer their customers cross-border transfers in a less cost on both parties.
Yeah, and I would add perhaps that it's easy to track along the way, and it's real time as well. So these are the added benefits of it. Okay, there's another question from Aisha. How do we ensure the security of blockchain technology going forward?
Okay. The security of blockchain. Is blockchain really secure? There are debates regarding this issue, and the debates are coming from the type of cryptography algorithms being used. As you might know, one of the oldest and most famous cryptography algorithms that are being used is the RSA. But if you look at the cryptocurrencies and the blockchain, you will be seeing that they are not using the RSA. Rather, they are using the elliptic curve cryptography in sake of a more secure and a more better performing algorithms. The RSA is a very long key that require too much computation, while on the other hand, the elliptic curve is a shorter key that gives the same level of security. But yet, both are being debated to be broken within the coming few years. And security algorithms are being studied by mathematicians to provide a better and more secure way of doing things, especially speaking when the Internet of Things is being introduced. We are concerned of finding mechanisms of securing these transactions. But to be honest with you, nobody can stop the debate, and nobody can tell if this is an ultimate security or not.
Great, thank you very much. I hope that addresses your question. I think we've run out of time, unfortunately. We've got plenty of questions coming in, and we thank you for your engagement with us, and thank you for joining our webinar today. Thank you so much, Mahmoud, for this really good presentation on blockchain. I hope it's managed to give some clarity on what this technology is and some of the potential use cases for the technology going forward. I know there's definitely a lot of potential for it here in Oman. Thank you so much for joining us, Mahmoud. We look forward to seeing you all tomorrow. Our next webinar will be held tomorrow afternoon. Please tune into our social media channels for more information. Thank you so much.
Thank you, everybody. Thank you for attending. It's been my pleasure to be here and to be able to provide some value. Thank you.
Thank you, Mahmoud.